We did the first question. Let's continue. Copy each of these diagrams and add one line segment so that the resulting figure has rotational symmetry but not line of symmetry. Okay, add one line segment. If I just look at this B part, I can think of this line. It would have rotational symmetry of order 3, but there will be line of symmetry. We have to make no line of symmetry. But it never said that it should have like uh, or rotational symmetry, how much rotational symmetry, like order 1, 2, or something. So whatever we draw, we just have to ensure that it would not have line of symmetry because order of rotation could be 1. So if I just add one line like this, it would have no line of symmetry, but 1 order of rotation. Or if I just ignore this and try this instead, it would have now 4 order of rotation, but no line of symmetry. Do you agree?
Yes, sir.
Any ideas about shape B? One line.
So there will be, if you add another line at the bottom, like the first one. Yes,
Nice.
sir.
Nice. Very good. So it will have order of rotation but no line of symmetry. Very good, Ali. Question number 3. Draw hexagon with 2 lines of symmetry. So we have to keep in mind that we need 6-sided figure and 2 lines of symmetry. So I'm just thinking elongated type hexagon. Now it may have one vertical and one horizontal line of symmetry. Number 4 says for each of the following shapes, find the number of line of symmetry and order of rotational symmetry. So square, how many lines of symmetry are there?
4. No.
4, that's right.
Yes.
Rotational symmetry, square.
One rotational symmetry.
This is square. If you rotate it in 360-degree, how many times will it fit in its original shape?
Oh, um,
Square would just put in
4
4.
times.
Yep. Rectangle, line of symmetry,
Same 4,
2.
2.
This is rectangle.
Yes.
This time diagonals are not line of symmetry.
Uh, how is that like? Oh, we need the same size.
Yeah, if you just like try
Yeah.
this triangle, see this corner is opposite to this side and there's nothing over there. If
Yes.
it was line of symmetry, it would look like kite. So it has 2 line of symmetry and 2 order of rotation. Parallelogram, line of symmetry. Parallelogram, line of symmetry.
I think so. 2 maybe.
Parallelogram line of symmetry are 0 and order of rotation is 2. Let me draw a parallelogram.
Oh yeah.
See, there's no line of symmetry, but the order of rotation is 2. Do you know what rhombus is?
No sir, I forgot the shape.
Rhombus is a tilted square. Difference between parallelogram and rhombus is this. It has all sides of equal length.
Yes, it's type of a square, but
Yeah, tilted square. How
square.
many lines of symmetry?
I think so. Four.
We will
It,
have two lines of symmetry. One is this diagonal, the other is this diagonal. And if you are thinking about this again, see, this side is acute angle, this side is obtuse angle. So this could not be the line of symmetry. There are only two lines of symmetry and two order of rotation. Now trapezium. I think the question is actually unfair if we just we may have different types of trapezium. This is trapezium having no line of symmetry and order of rotation 1. And if I just draw isosceles trapezium, it may have one line of symmetry. So let's consider that we are talking about this isosceles shape. So there is one line of symmetry and one order of rotation. What about kite? Do you have the shape in mind?
yes.
This is kite. How many line of symmetry?
None.
There are two.
Two. Yeah, I see.
No, there's
Then
one. One line of symmetry. Ali, are you with us?
Yes, sir.
This is the only line of symmetry and order of rotation. One.
Yes, sir.
Equilateral triangle. Line of symmetry. Equilateral triangle. How many lines of symmetry? No guesses? In
I
equilateral
think
triangle, there are three lines of symmetry,
Yes, sir. Yes, sir.
and order of rotation is also three.
Yes, sir.
A regular hexagon.
So order of rotation will be,
In triangle,
yes, sir, it will be one because,
so see, AB will land on BC, and then it would land
oh,
on
yes, sir. Yes, sir.
all
Yes, sir.
angles
Yes, sir. Yes,
outside.
sir. I get it.
Similar way, a regular hexagon, it has six lines of symmetry, and order of rotation is also six. Last, scalene triangle, that means all three sides are of different length. So how many lines of symmetry? Scalene triangle, lines of symmetry. Still thinking?
uh, it says three. I think none because
None, right?
none.
And our order of rotation, one, because all sides are of different size.
Yes.
Number five, how many letters of the alphabet can you write so that they have a line of symmetry? Write them down, drawing the axis of symmetry on them. So let's use some writing space. So I'll just quickly write so we don't have to think about them. So let's say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So line of symmetry in A, I have one vertical line. In B, horizontal. C, horizontal. D, horizontal. E, horizontal. Is there any line of symmetry in the next letters? F, G, H, so on. I think zero line of symmetry, zero line of symmetry. How many lines are there in H? Can you see any line in H? One horizontal and one vertical. So two lines of symmetry. What about I?
So in the letters one, I don't understand. Like
In the letter, what Haris?
I don't know how to make the symmetry in this one. It's like
You just have to see if you can draw a line that would look like a mirror, like just like a
oh,
we did in A. So this vertical line would split it into equal half on left and right hand side.
okay.
So similar way, if you're thinking about I, capital I, we can make a vertical split and
And
horizontal split.
horizontal.
For K, there is only one horizontal split. Zero for J, zero for L. What about M?
And we'll do it from the middle. So
One
horizontal.
vertical split.
Vertical.
What about N?
And I think so zero.
Zero, right? And O
Oh,
may
oh, we have to.
it may have many.
Yeah, many because it's a circle. Yeah.
P,
P zero,
Q,
also zero.
R,
Also zero.
S,
Also zero.
T,
From the middle, like
um,
from the top.
and U. Basically, this would depend on writing style as well.
Yes, if it's yeah.
So it has one.
Yes. We
V,
also have one
W,
from the middle. What is that?
X.
Uh, you have two, one horizontal and one vertical.
Two lines, right? Y
Why we don't have any?
and Z.
Also, we don't have
One.
any.
Again, Y would depend if we write Y like
Yeah,
this.
yeah, like this.
Basically, we have to think how it would be when we actually type them. So Y has one vertical line of symmetry. Okay. Problems can sometimes be solved by considering the symmetry within the shape. Example, in a kite PQRS, we can see this kite PQRS. PQ is equals to PS because we know the geometry and we know the symmetry. So PQ is equals to PS and RQ is equals to RS. Angle 40 is given and QBS is equals to 100. Find QSR. This is Q, that is S, and the bottom is R. So I'm using this as isosceles triangle. So we take away this 40 from 180 and divide the remaining. Then it says find PSQ. Similar way, we take out this 100 from 180, we are left with 80. 80 divided by 2 is 40 each. Then PQR. PQR, that is just 70 plus 40, that's 110. Practice exercise. In a rectangle KLMN, LNM is 34. So KLMN and LNM is 34. Calculate KLN. This is K, this is L, this is N. What would be this angle? This is a rectangle. We should know the geometry of the shape. This is 34 degrees, and the reason is alternate angles. These two sides are parallel, and this makes it alternate angle. The next one says KML. This is K, that's M, and then L.
Sorry, so वो भी 34 होगा.
Yeah, the top one is 34, and this one, need to find this.
Sir, yeah, 91. So yes, sir.
So 90 minus 34 is 56. Now, how do we actually came to know that this is 34? Was due to symmetry. We knew that this is line of symmetry, so left hand side and right hand side would be equal in case of these diagonals. So this is 34, that's 34. Or in other ways, we could have just found this angle, which is 56, and we also have horizontal line of symmetry. So if this is 56, this is 56. So sometimes we use line of symmetry to solve for unknown angles. In trapezium ABCD, ABD is 35, BAD is 110, and AB is parallel to DC. Calculate ADB. So ADB is this angle. We already have two angles. 180 minus 110 minus 35 is 35. This angle is 35. Then BDC. BDC is this angle. When we look at the parallel lines, this makes it alternate angle. So straight away equal to 35 as alternate angles. Try question number 3. Parallelogram. 72 is given, 80 is given. Calculate WZY. Think about it, that's an easy one.
Sir, it's a the lines are parallel, WZ and XY. So
Okay.
it will make a Z, and I think mm,
What
that's also gonna be 72
what is yeah, that will be
parallelogram. 72, yes, sir.
it is parallelogram, and we know parallelogram has order of rotation 2.
Yes, sir.
When we'll rotate it one time, this will land over here.
Yes, sir.
So that's just 72 because
72, yes, sir.
we and then x w z.
XWZ will be
X w z is this full angle.
yes, sir, and
And we know this that when we have parallel angles, parallel lines, sum of these two is always 180.
yes, sir.
And the property is interior angles between parallel lines. So this
Yes,
is
sir. So
180 minus 72.
80
10.
minutes.
No, he was asking
20.
full angle.
Okay, yes, sir. Yes, sir. Yes, yes, sir. Yes, sir.
XW. And the last one is
WY and
WYZ.
that's if we have 80 and 72, then we can find that angle. Think
That's right. I'll
Pythagoras
go
theorem.
for this side. 108 minus 80.
Oh, yes, sir, yes, yes, sir.
But that's
So,
all.
so we have 80 and we have 72.
Yeah, that's true. That's true.
Yes, sir. Can we use Pythagoras theorem?
I know we are working with angles. Angle sum of triangle is equal to 180. So
Yes, sir. Oh, yes, sir. Yes, sir. Yes, sir. Yes, sir.
plus 72 plus unknown
Yes,
angle.
sir. Yes, sir. Yes, sir. Okay.
Pythagoras is for length.
Yes, sir. Yes, sir.
Yeah. From question 4 to 8, begin by drawing a diagram. So in a kite, 4 to 8, we'll just do two of these in detail. So we first draw a kite. A, B, C, D. So let's say the kite looks like this. A, B, C, D. It says AB is equals to AD. AB equals AD. So we are changing these vertices A, B, C, D. AB is equal to AD done. Then it says BC is equal to CD. BC and CD done. Then it says CAD is 40 degrees. So I'm drawing this line and CAD, this side is 40 degrees. Then it says and CBD is 60 degrees. So we need one more line where CBD this side is 60. And now calculate. So we're calculating for BAC. May I just say without working BAC is 40 because of the symmetry, vertical line of symmetry. And then BCA. Can you work out C? What is the value of BCA?
So it's gonna be 40.
No, that's not 40
Yes,
because
sir.
kite has order of rotation 1
So,
and only vertical line of symmetry in this case.
so B is 60.
At
Or
B,
that's
angle is
60.
60. We
Yes,
need
sir.
to work out BCA, this half.
So 40 and 60.
No, we don't have this upper part.
Oh,
60 is just this portion.
Yes, sir. And 40, 50, 20, 40, 40, 60.
Haris, any input?
Uh, yes, sir.
You are forgetting the geometry of the shape.
So isn't
The diagonals of the kite intersect at right angles.
yes, sir, right angles. So it's 60 and
This,
90. Yes, sir. Yes, sir.
so 60, 90, this comes out to be 30 degrees.
Yes, sir.
C part says ADC. Now you can just copy that 60 on the other side. And if that's 40, this is 90, this is 50. So ADC is 110.
Yes, sir. Yes, sir.
Okay, select any out of these. We'll try one more. C rhombus, rectangle, trapezium, parallelogram. Which one you wish to try now?
Thomas.
Rhombus? Okay. So question number 5 is rhombus, and it looks like a tilted square. All four sides are equal. That's a rough attempt. And it says ABC is 64. See that, and this is 64 acute angle. And it says calculate BCD. BCD unknown. What is the value of BCD? By the way, property of rhombus is all four sides are equal in length and opposite pairs are parallel to each other. Now, if that may help, what is angle BCD? We just did something related to it over here. Angle between parallel lines are supplementary. 180 minus 64 is 116. This is 116. Then it says ADB. What is ADB? This part. This is rhombus, symmetry of shape. If that's rhombus, that means we can draw this as line of symmetry as well, which splits that 64 into 32 and 32, making it 32. Last one is BAC. So BAC, similar way. We have 64 and these two are equal because it is isosceles. BA is equal to BC. So 180 minus 64 divided by 2. 116 by 2 is 58. Are these angles clear?
Yes, sir.
Yes, sir.
Okay. Axis of symmetry. Now we are moving toward 3D shapes. An axis of symmetry is a line of three-dimensional space around which a solid shape has rotational symmetry. The hexagonal prism, for example, has an axis of symmetry running through the middle of it. The order of rotational symmetry is the number of times the shape coincides with itself as you rotate it through 360. For a line to be an axis of symmetry, the solid must have rotational symmetry around it of an order greater than 1. So the hexagonal prism has a rotational symmetry order 6 around the axis as shown. So if we have those axes, this is side 1, side 2, side 3, side 4, side 5, and side 6. So we can rotate this 6 times so that it would fit in its original shape. So order of rotation about this given axis is 6. The diagram shows the axis of symmetry of the cuboid with square cross section. What is the order of rotational symmetry about the axis? Square cross section. So if we would just rotate it, how many times will it fit in its original shape while we rotate 360 degrees? No guesses? This is side 1. When you rotate it, it would definitely fit on side 2,
Two and then
side
three
3,
and four.
then side 4. So we have
Yes, sir.
4. Order of rotation is 4 because
Yes,
that's
sir.
square. For axis of symmetry of the cube as shown, for each axis state the order of rotation symmetry. Now, if I would
This will
just to
be
rotate it about this or this point,
four.
yes, there are 4 different positions
Yes,
where we
sir.
can rotate and it would go unnoticed. Now, this
Yes,
is the
sir.
axis. We cannot move the axis, but we can rotate definitely. I can
Rotate. Yes, sir. And then
hold, put, grab this point and rotate.
yes, sir. Yes,
So,
sir.
how much is the order of rotation for this case?
Two.
This is 2, that's right.
Yes, sir.
And C again
Four.
is 4. What about D?
This will be. This will be one, two, four, two or something.
That is 2, right? Because
Yes,
this
sir.
line would switch with this line, and in
Yes,
the
sir.
next
Two.
round, it would come back.
Yes,
Or
sir.
we can also say that this cross section will switch its side with this cross section, and in next round, it would come back. So this is again 2. A cuboid
Yes,
has
sir.
3 axes of symmetry. Copy the cuboid below and draw the axis of symmetry. So I'm drawing 3 axes of symmetry horizontally, and I'm crossing through the middle of this,
Yes, sir. And then
and
the top two.
that's right, from the top and from the middle,
Yes, sir.
that's an exit. And the third one is into or out of
Diagonal.
the edge. So we would just bring
Yes, sir.
in and take out of the other side.
Yes, sir. Yes, sir.
So 3 axes of rotation.
Yes, sir.
And order of rotation about these axes would be different story.
Yes, sir. Yes, sir.
Angelique says that the line she has drawn is also an axis of symmetry. Is she correct?
Uh, mm, yes.
CLE,
Hmm.
let me say this is 4 centimeters and this is 1 centimeter.
Oh, I thought it was coming from the.
This is actually not equal. So if I would
Yes,
rotate,
sir. Yes, sir.
when I rotated 180 degrees, now this side would be 4 and the other would be
Yes,
1.
sir. Yes, sir. So there's
Definitely.
no. Yes, sir. Zero.
It
So
is
these
not
are
saying
correct.
about that. So not correct.
Yes, sir.
Correct. That's a no. Number 5. A cylinder has an axis of symmetry running through middle of it as shown in the diagram. Does it have any other? If so, what is the order of rotational symmetry around each of these other axes? So, is there any other axis of rotation for this cylinder?
There is, sir, there's a lot like from the top.
Yeah, there are a lot. If we just would penetrate from top
Yes,
and
sir. Bottom.
take it out from the bottom, and it has to be equal actually on both sides. And
Yes, sir.
so we can do this at many different places.
Yes, sir. Yes, sir.
But whenever we draw this, there the order of rotation would be 2.
Yes, sir.
Because when we just rotate, this cross section would go on the other side and land, and in the next attempt, it would come back.
Yes.
Number 6. Name a shape that has infinite number of axes of symmetry.
Sphere.
Correct. Aris, last one. The
Okay, sir.
cross section of the prism is an equilateral triangle. This is the cross section. Equilateral triangle. How many axes of symmetry does it have? Axis of symmetry. Keep thinking and dictate me. I'll draw.
Yes, sir. Okay. So, one is one will go vertically.
One would go vertically, entering from this midpoint and leaving from this midpoint.
Yes.
So I'm just taking this as a base example and drawing 3 of them. Coming from this point and leaving from this rectangle. And similarly, third one entering from this point and leaving from the center of the other. Any else other than these?
No, I don't think.
What about we come from the side, enter
Oh,
center,
okay.
and leave from the center on the other side?
Yes. Yes.
So we actually have 4 axes of symmetry for this shape.
Okay.
Ali, any objection in this? Okay, for today, if you get time, do try these. We've just done 4 and 5, 6, 7, 8 are still there. And do check your answers if you get same.
No, okay, sir.
Tomorrow we'll do planes of symmetry. We just did axes of symmetry. Tomorrow
Yes.
it's planes of symmetry.
Okay, sir.
Anything you would like?